Hello, hi everyone. Welcome to my channel Samuel Flying Birds. Today we are going to discuss about chapter 2 of 10th class mathematics about sets and unions. In the previous class we have discussed about related to sets and some of the terms which are related to sets and how they are being used in the sets, and we have did some of the problems related to sets. Now today we are going to discuss about what is a universal set and subset and other related topics. What universal set and subset? A universal set is a set which has element of all the related sets without any repetition of elements. It is denoted by U. Means we are having a set which consists of all the elements including alphabets or a number, or it may be anything, but it is related to only one set of elements, and it is a complete one related set. All other sets are subset of the universal set. We know that a complete set is of only one type. From that, if there any other sets which have been subdivided are called as subsets. Coming to the Venn diagrams, what is Venn diagram? A Venn diagram which shows logical representations relationship between a finite collection of sets. There are some basic Venn diagrams which have been used and basic operations which have been used in the sets. Coming to first one, union of set consists all elements of set A and set B. We know that union is completely related to the set of both the elements of both the sets. Coming to next one, intersection of set consists only the common elements of set A and set B. We know that the intersection means the common term of both the set. Coming to the next one, complement of set consists of elements which do not belong to set A. A set A consists any element, it should not be related to the next set or the other set which is been in the universal set. So the complement of A is nothing but except set of A remaining all the terms in an universal set or in another set like B, it is called a complement of A. Symmetric difference of sets. Here we are going to decide what are the difference in a set. Consist of elements in a set A and B but not in their intersection. The difference between intersection and difference of sets is very different in a similar way. In an intersection we consider the common term, but here we consider the total terms which are being set A and set B except the common terms of set A and set B. We are not considering the common term of A and B in a simple way. Coming to some of the examples. First example, the whole numbers. W is denoted as the whole numbers. A is a set and B is a set given. set A consists 1, 2, 3, set B consists 6, 7, 8, 9. Here we are solving what is A intersection B and what is A union B. In an intersection, there is no common term between set A and set B. So the intersection is 0. For A union B is complete set we need to define. We need to combine both the sets is the meaning of the union. So we consider the terms or elements which are in A and B. So A union B is equal to 1, 2, 3, 6, 7, 8, 9. Coming to example 2, W is a whole number. C and D are the two sets which are being given. Here also the same way we are going to find C intersection D and C union D. C intersection D is expressed as the common term of C and D. There are two elements in C and D. They are 3 and 4. The union is considered the complete set of C and D. It is given as 1, 2, 3, 4, 5, 6, 7. For example 3, W is again a whole number, or we can call it as a universal. Here two sets are being given, E and F. Here the same procedure we are going to solve. E intersection F and E union F. Here E intersection F is equal to E. Why? Because what is the term which have been present in E and F or a common term in E and F are also present in E. So we can consider E intersection F is equal to E because both the terms are related to each other. E union F, we can call it as E union F is equal to complete set of F because the F is related to E. So the complete set F is being expressed as E union F. Coming to the fourth example, the integers are given here, the whole number and the natural numbers. Here we are going to find whole number intersection natural number is given as whole number is W and natural number is N. Whole numbers are from 0 to infinity and natural numbers are from 1 to infinity. So we can consider W intersection N as N and W union N as W. So N is a subset of W. Coming to example 5, here real numbers are being given and Q the rational numbers, Q bar the irrational numbers. Here the three terms have been given. Here the Q is considered as any terminating or repeating decimals and Q bar is any non-terminating and non-repeating decimals. We know that repeating are different and non-repeating are different. Real numbers are different and irrational numbers are being different. So for the first one, Q intersection Q bar is given as empty set or a null set and Q intersection Q bar is given as real number. For the example 6, quadrilaterals are being given, rectangles and squares. These three terms are being interrelated to each other. Here are a quadrilateral with opposite sides congruent and a right angle. And S is a right angle with all four sides congruent. We know that a square is completely equal to the all four sides, and rectangular has only two sides been equal with right angle. So R intersection S is equal to S and R union S is equal to R. So S is a subset of R. I think you have understand all these examples, and A minus B and A plus B are similar to A intersection B and A union B. A minus B is equal to A intersection B and A union B is equal to A union B is equal to A plus B. In the intersection, we are taking the common set of A and common element of A, set A and common element of set B. But in A minus B, we are considering the terms which are not being present in the set of B, and we are subtracting the terms from A, and the remaining terms which are present in A we are considering it as A minus B. By this we have completed our sets chapter. I think you have understood all the problems, so that we can solve all textbook problems and complete our chapter. If any doubts, please comment on the comment section with your question, so that I can explain all the related problems. And thank you for watching my video. Thank you.